Okay guys, this is the Making Connections with Factoring video. I'm going to go over these questions that I have circled. So just make sure, obviously there's not, for most of these, this first column, a lot of these there's enough room to just do these in the first column. But after that, you're going to pretty much have to have your work on a separate sheet. So I'd just as soon it all be in one place. So notice you have factors at the bottom. So if once you factor this and you can't find your correct factors at the bottom of this thing, try again. All right, we're going to work these. Okay, number one, at first it appears to be a quadratic, and well, it is a quadratic, but you're not going to have factors as in binomials because there's a GCF. Every single question we work on here, first thing you should do is make sure, and we can actually write these down. First thing you should do is always combine like terms. Most of these there aren't any like terms, but if there are, do that first. Second thing is always look for GCF. Okay, greatest common factor. If there is one, take it out. No matter what, do that first. And the third thing, factor. Okay, so on this one, always again, first thing combine like terms. These are not like terms, so the next thing I'm going to find the GCF. The GCF here, I've got an x squared here and an x here. So they have that in common. They both have an x in them. So I can factor out an x here. So when I factor that out, I have one x left over. Minus, when I factor x out here, I have a y left over. Now at this point, if I were to go back and check this, if I distribute this x back in, I would get this. When I'm at this point, I want to look and see what's in these parentheses. If I can factor this, I want to factor this. I want to factor again. But x minus y, that's broken down as small as it can go. I can't combine it. There's no quadratic. There's nothing I can do with that. So I'm done. Okay? All right, on 24, I'm going to follow these three steps right here again. First thing, combine like terms if there are any. There are. So I don't want to leave those separate. This actually isn't a this actually is a trinomial. Negative 28x plus 7x is actually negative 21x, okay? Minus 49, and then the 4x squared, of course, will drop. Then I'm going to look to see if there's a GCF. That's the second step. Is there GCF? We've got 4, 21, and 49. No, those are not, any of those are not divisible by any of the same numbers. So that means I'm going to use my little chart method. I need the first number to be what they add up to and the second number to be A times C. So B here is negative 21. So I need them to add to be negative 21, but I need them to multiply to be whatever 4 times 49 is. All right, so 4 times 49, if I put that in my calculator, I need negative 196. Okay? Now, negative 196 is a pretty big number, so this is going to be a pretty drawn out one. But all right, 196 is kind of an ugly number, so, you know, and obviously 1 times 196, that's not going to give me what I need. And I know 4 divides into it because I multiplied by 4 to get it, but 4 is probably not going to be close enough either. So I know I got 4s and 7s from the 49, so 4 times 7 is 28. So if let's see what 28 works. 196 divided by 28 actually is times 7. So those are the factors we'd want. Now we want negative 21, so I want negative 28 and plus 7 on that. Okay? So what I actually have here is x minus 28 times x plus 7. Okay? Now, unfortunately, we're good so far, but this doesn't give us the 4x squared. So I need to take into account the 4. So really, I'm going to go back and divide both of these by 4 and then see what I have. 28 divided by 4 will reduce. 28 divided by 4 is 7. 7 times 4 is 28. And then this one, 7 over 4 won't reduce. So instead, I'm going to have 4x plus 7. If this won't reduce, and what I have left over goes and chunks out in the front. Okay? So this is my final answer. I'm done. Okay? All right, on 29, again, I have 4 terms, whereas the one we just did, the 2 middle terms are combined. It had some like terms. But this one, if you'll notice, these are all totally different terms. So what I have to do on this instead is I'm going to try to see if grouping will work. So I'm going to group this and see if it does what I want it to do. These grouped together both have an x. So I'm going to distribute out an x. So that would leave me x squared divided by x is x, and xy divided by x is just a y left over, and that's minus y. Okay? Plus, these have a 3 in common. So I'm going to distribute out a 3. So that would leave me with x minus y. Okay? Now this did exactly what I wanted it to do. Notice when I grouped it and factored out a GCF, see how this is exactly the same as this? So that means this now is the common factor. So I'm going to factor it again. I got a common factor of x minus y. So I'm going to factor out x minus y, and what I would have left over here is just a plain old x, and what I'd have left over here is just a plain old 3. And so those would be your final factors. Okay? Okay, on 31, I want you to label this a DOS. DOS stands for difference of squares. Difference meaning that there's subtraction, and squares means that these are perfect squares. If you have a quadratic, and these are quadratics because they've got the highest degrees of 2, and it's a binomial, you need to stop and look at each term and see if they're perfect squares. Well, they both are. 49, the square root of 49 is 7, and the square root of y squared is y. So this one is a perfect square. And then over here, square root of 4 is 2, square root of y squared is y. So both of these are perfect. So when you have a difference of squares, these are going to factor into their perfect squares. You have 7x, I'm sorry, not x, let me go back. 7y, and 7y will give you 49y squared, and then 2y times 2y will give you 4y squared. Well, there's no middle term here, and when we FOIL normally, we should have a middle term, the o and the I. Well, the reason we don't is because I need different signs to produce the negative 4y squared. So that means that this middle term, so that's our answer. But when we go back to check it, the outside is negative 14y and the inside is positive 14y. So that means that those two cancel each other out. That is why there's no middle term up there. All right. You know what here? Guys, I just realized I messed up. So let me fix that just real quick. This is actually x. So that makes that a x. So that makes that a x. Okay, so let me go back and fix this. So 49x squared. Everybody okay with that? And then, so that would be this 7x and 7x. My bad. Otherwise, those x, those y squares I could have combined at the beginning. So this is what it is. So fix that. All right, on this one looks real ugly to begin with, and it is kind of ugly, but remember our steps are to combine like terms, which we don't have here. The second step would be to do GCF. So I need to look see if there's a GCF. Well, there is. There's a 3 in both, and there's also an x in both. So I'm going to pull that out of those. Okay, so when I factor out the GCF, I get 3x comes out, so I'm left with x squared y squared minus 3x divided by 3x. Is when they cancel, don't leave it blank or don't put a 0. It's 1. Anything divided by itself equals 1. So I'm left with this. All right, this is kind of ugly. And the GCF I pulled out, but I need to go back and look and see. Remember when I said this is a quadratic? Okay? Or this has a power of 2 over here. So if I think about these separately, when I only have binomials, see if they're perfect squares. The square root of x squared y squared is xy. Because remember, this is what this means. X times x, y times y. So a pair of x's and a pair of y's broken down would just be 1x and 1y after take square root. Okay? Just like square root of 4 is this. Okay? You have a pair of 2's, that's why your answer is actually this 2. Okay? So what we actually have here is a difference of squares. And remember back when we talked about difference of squares, those will separate. So the square root of x squared y squared is xy, square root of x, and so I have xy times xy. When I multiply those, I get back to the x squared y squared. And of course, the square root of 1 is just 1. So this would be 1 and 1. And it's a difference, so I have to have plus and minus. Now, there's no middle term here on a trinomial because the outside and inside would cancel. Negative xy for the outside plus xy for the inside cancel out and give you 0. So that's why there's no middle term up here. So that is my final answer.